Alrighty, Mr. GK here. Well, I'd like to start this video off by saying that a lot of these other guys that does what I do, a lot of them were very fortunate to grow up in this hobby, which I really wish that would have been me. Who knows how far I would be in doing what I do now. But I grew up a little different. I grew up pretty much a computer nerd, old school gray hat computer hacker back in the old dial-up days. Yeah, I can sit here and say on video that I used to be a hacker growing up. I ain't done no hacking since before I got a license for a car. But anyway, age 6, I got my first computer. By age 10, I was already writing code, programming for using. Well, I started off with QBasic, but for DOS. But I started off programming using Microsoft's programming suite, which is Microsoft Visual Basic. So I grew up a computer nerd, which really wasn't that cool at school because computers wasn't like they are now, where every kid's got one in their pocket. And so I kind of had a little close-knit friends at school that I pretty much taught them, and before you know it, I had a little a war is, however you want to say it, club of nothing but young Southern computer hackers in the old dial-up days. So I grew up a computer nerd, and I didn't find this hobby till about 6 or 7 years ago. And it would have been awesome to be able to have been in this at an early age, but I've definitely met a lot of people, quite a few people along the years that's helped me, get further ahead in my knowledge and wisdom when it comes to this type of stuff. And the guy I really want to talk about right now that got me to this level that I'm about to be demonstrating is my buddy that I call the genius. And the reason why I call him the genius, because in my eyes he is a genius. I hope to one day understand a portion of RF or electronic theory as he does. And when I first met him about 2 years or so ago, I believe it is. I'm not too good when it comes to year numbers, right off the top of the old dome here. He had actually already constructed one of these type of amplifiers I'm about to show you now. And I kind of demonstrated and showed him, hey man, we got a guy right now in the scene that's working with LDMOS, Mr. BBI, Mr. Luke Miller, and demonstrated, showed him some of his videos, and I was like, man, it'd be really cool if we could get into this technology, and he's like, oh, we can do it, we can do it. And right then and there, the idea had hatched, and he already had the idea before he even met me that it would be neat to get into this technology. So me and him coming together just, I guess, threw the spark off, and he got to going, man. And the way we kind of wanted to do this was, and he agreed with me, is try not to use any other designs out there as a reference really into the design, to where pretty much he wanted to start off from scratch, just using a data sheet, and just to design a palette, a amplifier board that is purely designed for us, for what we are doing on the frequencies that we use them for, but also to be broadbanded, that can easily be used for the full HF spectrum. So he is the brains behind this whole operation, and I give absolute major shout out to him, Mr. RF Man, aka the genius. Without him, this wouldn't be in existence, by no means. So here we have my very first constructed single BLF188XR bass amplifier. A really cool guy, which I believe he wants to remain anonymous, so we'll keep that, respect that. He had a couple ideas he wanted, a couple of bells and whistles, as you can see. And basically he wanted 2 separate attenuators to accept the 2 radios that he possibly will be using. So that definitely took a little bit of thinking on how I could do that and switch them in and out. Which, you know, after drawing a couple of diagrams and this and that, I finally figured it out, because the deal with these attenuators here, this is kind of a T-style attenuator. So you have a resistor here that's shunted to ground. So to use 2 separate attenuators, you have to completely take the attenuator out of circuit completely when you're switching in between. So if there's a lot of you already know and some may not, this is a LDMOS device. I believe it's laterally diffused metal oxide semiconductor, I believe it is. I could be wrong. LDMOS. It's an LDMOS transistor. These bad boys are a lot more efficient than what we're used to, a BJT style transistor, you know, 2879, etc. And these bad boys can be up to over 80+% efficient. For the frequency that we're using right now, we're looking at around 75 to 80% efficiency, possibilities of 75 to 80%. Of course, it runs on 50 volts. This is the power supply right here, which is actually oversized for the device. The guy wanted a oversized supply and also a oversized heat sink, and as you can see, this is a big heat sink. But basically, these devices take very low drive. Very low drive. All it takes is 1 single watt to drive this device. A single device. 1 single watt to a little bit over 1 single watt, you can achieve full output out of this bad boy, which is absolutely amazing. Now, one other neat thing about this design, if any of you have seen other LDMOS circuit designs, a lot of them use a different procedure on the output impedance transformation circuit. And the cool thing I do love about this design is it's basically keeping the same look, the same flow that a lot of us is used to. And it is Mr. RF Man utilized an output broadband transformer, which is really cool. It does, in my eyes, make the production a little easier, a little bit less time consuming. Maybe not in some other people's eyes, but in mine it does. This thing is sitting on a very thick 100% copper spreader. And you'll see a lot of other designs. A lot of them will use the broadband transformer for the input, but most of them, like I have to say, probably 9 out of 10 designs I have personally seen, they'll use a different, like type transformers for the output. They doing the same thing. They just look a little different physically. Sometimes split up into 2 ferrite beads, sometimes 4. Using 25 ohm cable. We won't get into all that. I just kind of want to keep this video kind of short and sweet. This is the first build. And another thing that the fella wanted was a thermo protection circuit. So basically that's what you're seeing right here. Okay, this is a switch right here in the back to turn it off and on. So let's say, for example, he feels that it's just going in protection too soon, or he just doesn't want to use the protection circuit. It gives him some flexibility to be able to turn that off and on. And basically the way it's set up is the protection thermal switch is actually right here at the very corner of the heatsink. So this very corner of the heatsink has to get around 118 to 120 degrees. The very corner. And as you know, the heat's going to disperse from the middle out. So this corner right here gets about 118 to 120 degrees. This relay is going to throw and disconnect the power to this relay, and the amplifier will be unusable. And of course, this LED right here will come on. And of course, once it cools down, it'll be, go back to normal use. So that gives them a little flexibility though, and gives it a little bit of protection when it comes to heat. And just in case you're wondering, this perf board right here is the keying circuit, utilizing a optocoupler, which is Mr. RF Man's design. Very cool design there, which keeps everything isolated from your input tune. Keeps the RF completely isolated, which is really neat. And so we are rocking with a Meanwell RSP 2000 on this bad boy. This thing is oversized. He will never use the current that this thing can give, nowhere near its max. He's probably going to be using around 60% of the power supply. So you've got some headroom there. That's a good thing to have. And a lot of you are probably wondering, or some of you may be wondering, why in the world these capacitors so long length? When you're dealing with the output transformer, tuning the circuit on the output here, that much of a lead length can mean a difference of 200 watts. It's crazy. It's different than what I'm used to, but it is what it is. And so you just got to roll with the punches, man. And you know, just took a little bit of, and it's going to take a little bit of getting used to. It's already took a little bit of getting used to working with this type of technology. It's very, 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 very cool. Another thing I went ahead and did for him too is he's got a port right here on the back where he can plug in an amperage meter. Okay, and instead of cutting it out and putting it right here, which I could have done, but this decision was made after the amp was built, and I didn't want to have to get in here and worry about all the shavings going on. That's stuff you do when you're first putting an amp together. I went ahead and just put a port on there so you can just plug one in. So you see now it's plugged in. So I'll be sending this right here to him. I'll probably put that in a box, or if he wants to put it in the box, you know, whichever's clever. And let's see here. I'll show the front. Again, right here, it does look like a mess of wires, but to switch these two attenuators in and out, and as you can see, this right here is one attenuator. This is the one that I actually put together myself, and this right here is an attenuator right here that was that I had purchased. That's a flange mount type attenuator. So, but you know, there's a good bit of wires here in the front because you got a little bit of coax going back and forth to be switched in and out, which is this switch right here. Okay. And basically what you're looking at here is here's your on and off switch for the amplifier. Okay. This right here is your SSB delay. And the reason why I don't have the labels on here yet, I've went ahead and ordered, because with this right here, I'm going to need to basically put negative 10 dB right here, and then at the bottom, negative 16 dB. This is the attenuator switch right here. SSB delay. This is on and off. Okay. So let me go ahead and get everything ready here. Make sure I got everything plugged in good, and we'll go ahead and demonstrate this using my bench radio at first, which of course it's not going to drive this thing hard at all because the attenuators are set up. So we'll just start off with the bench radio just so you can see what it will do with that type of drive, and then I will hook up my pretty much the strongest radio I own at this moment, which is my Superstar over there. I have one more radio. It's down right now, and being repaired. It just kind of croaked on me not too long ago, so it's being repaired. But this would be something good to work with to at least show you what the amplifier is capable of doing with this amount of drive that I will be giving it, which is really neat and really cool. So give me 1 second and I'll be right back. Alrighty, before we get started, I just want to show you the feed through tune and how much we're going to be putting through, or just let you see the RF flowing through the box without it turned on, which I had to do a little bit of tuning for that. That's just this capacitor that you see right there, that maroon capacitor, which sometimes you have to do a little bit of impedance correction with certain relays. And so this thing is absolutely flat now. It's a 5-watt slug in reverse. Oh, yeah. I don't even know if there's even any movement. And that's exactly what you want. Alright, so I'm going to go ahead and turn that forward just so you can see how much we're going to be putting into it now. Oh, that's 4 watts RMS, and we're dead keying about 1.6 to 1.8 watts, and that's what it takes to key this thing on AM. Oh, 4 watts RMS. And that's going to be peaking anywhere from 15 to 18 watts. Sometimes it may even be doing 20 on a good day. So that's what we're going to be putting into it first. Go ahead and turn it on. Now these Meanwell power supplies, man, these things are protected inside and out. They have every type of protection I think you can put inside a power supply. That's one reason why they are so expensive. I still put a circuit breaker in the back just to be safe. When this power supply begins to have amperage pulled from it, the fans will speed up. So that's what you're going to be hearing whenever I key down. Yeah, sounds like a dang plane letting off or something. But basically, the more current you pull, the little faster they spin, because you know, these power supplies are designed to have a certain amount of duty cycle. So if you're using these things for a constant amperage pull, then fans are going to, you know, compensate for that to keep it cool and speed. So we'll take a look at the RMS first. I will show the amperage meter too, since we have that hooked up. I'm going to go ahead and turn this soldering iron off just in case I knock it with my hand or something. So we have the 1000-watt slug in. Okay, I'll just show a dead key real quick. Now keep in mind, this switch is up, so I have the 10 dB attenuator, negative 10 dB attenuator switched on. Okay, so my radio is flowing through this attenuator, so it's going to be knocking my signal down negative 10 dB from where it's at. Okay, now, I can't do that in my head right at the moment to tell you how much that is, but it's going to be driving the amplifier with way less than 1 watt. Let's just put it that way, less than 1 watt. Alright, so this is what we're getting a dead key. Now I can get this thing to focus here. So we're getting about an 80-watt dead key. Okay. So a little bit over 200 RMS. Let's take a look at the amperage swing. Okay, the volts are right there, about 50.8 volts. Just to let you know, right there at 50.8 volts. That's upon transmit. So it's pulling a little bit over 10 amps, as you can see. Oh yeah. Input reflect. It's a 5-watt slug. Oh yeah. Oh yeah. See right there, just about a 1/4 watt of input reflect. And one thing I did notice, that whenever I did introduce the attenuators. I did notice that the input reflect came up just a tad bit, which, you know, whenever you add something in line like that, that's going to happen. But it's still at a great, good low level, which is a good thing. I was hoping that was going to be. If not, I was going to get in here and change the input circuit a little bit, which is not supposed to. You're not supposed to need to do that with the way he has these boards designed. So that's good. And without the attenuator in, I mean, it wouldn't even move. I mean, it's very, very, very well tuned on the input. All right, so it's doing about 200, a little bit over 200 bird already, just hitting with that. And I'll let you take a look at the peak watts. Oh dear. Oh dear. Sorry about that. My mic, I need to dang replace that end on it. Sometimes it kind of messes up on me. So it's doing right there about 600. Oh dear. Yeah, a little bit over 600. PEP already. Now just for the fun of it, I'm going to go ahead and flip down to the 16 dB attenuator. And see, and this right here will also give the user a little bit of control on the output. These things take so less drive to get them going. It introduces all of us that's used to BJT style amplifiers, where we're just, you know, we're having to drive these things to get power out of them because they're so less efficient and so low voltage, that this introduces a whole new game. You know, now all our radios are too powerful, so we have to introduce attenuators to knock down that power. And so, you know, this right here will also give you a way to bump that power back on it if you're not wanting to run this thing at full tilt. So it gives you a little bit of a control there. And I'm going to be looking into some variable circuits possible in the very near future. We're going to have a lot of cool upgrades and bells and whistles that you can, you know, incorporate with these boards. And I mean, this is only the beginning. This is only the beginning. All right, so we got it now on the negative 16 dB. So let's see how less it's doing now, just for that. So it's doing right there about 650, a little bit over. Oh, look at that. Oh, yeah, right there about 400 if I hit the tone just right. Take a look at the amperage now. Oh, yeah, about 8 amps and 50 volts. Let's take a look at the RMS now. We're on the negative 16 dB attenuator. Oh, yeah, about 80 amps. About what it was dead keying before. Alrighty. And about the other two things that I can mention that I forgot to mention before, that the bias, okay, as you can see, there's two separate bias adjustments here. These are set at around 1.7 volts, okay. A lot of guys have their little ways, you know, a lot of them like to bias a little higher, you know, some a little lower. This is just the best optimum voltage that we have found just testing and such, that this is about the best optimum setting. You know, you can bias higher and you're not really going to get much more output out of it, and that's as well on the voltage. Some of these guys run these devices all the way up to 54 volts or so, and of course you're going to get more output of it as well. But I mean, you want to go at 50 volts, or you want to go to 54 volts and gain just a little bit of power, put more stress on the device, and these things are not cheap. Are not cheap. You're looking at around 200 bucks a device. That's not cheap. But if you take what this equals to with a BJT amplifier, I mean, it's done. It's said and done. I mean, one device per 8 to 12 devices to get the same output. That's the beauty of it, man. That is the beauty of it. All right, so what I'm going to do now, and like I said, I don't really have, this is the highest output radio that I own right now. I do have a ham rig that's hasn't even been took out of the box yet. That's still in the box. I don't even plan on opening that thing until I get my building actually set up, but just so you know, I ain't fibbing. This is the strongest radio that I got right now. The other strongest radio I got is a Cobra 29, but it's being worked on right now. All right, this right here is a Superstar radio. It does about 12 bird, and it peaks about maybe 40 to 50 watts peak. So I hate to say I'm not even going to be able to drive this thing to get full output like I would like to see out of it, but you know, it just is what it is. Before I put the attenuators on, just while I was tuning the amplifier, just with my bench radio, I was able, of course, you notice it's being overdriven just a tad bit with my bench radio. I had it cut down a little bit, but I was able to get, I think, if I remember correctly, around 13 to 1400 watts, somewhere around that area. And if you take a look at the device here, I'll just show you real quick. Let's see if I can zoom in here. So this thing is usable all the way up to, I thought it was 600 megahertz. Yeah, all the way up to 600 megahertz. Sorry about that. Had a call this late at night, man. I don't understand why some people call me at 3 or 4 o'clock in the morning. I guess they know that's when I'm working, but that's the key thing. That's when I'm working. But anyway, let's see if I can keep this steady. Sorry. So 2 to 30 megahertz, which is the range we're in, you're looking at about 1270 watts output at 50 volts. That's 29 dB of gain at 75% efficiency. So, and still though, if you drive it right and it's sitting on a good voltage, I mean, you can get up to 1500 watts out of a single device. But I'm gonna go ahead and tell you now, the difference of 1270 watts or 1200 watts and 15 is no dB difference. Nobody's even going to be able to tell the difference on the other end. But of course, I know we all want to see that output as high as we can make it. All right, so let me go ahead and hook up the Superstar here, and we'll see what we get out of it with that amount of drive. Alrighty, we'll actually go ahead and put the radio on sideband, just so we can demonstrate that the amp works just fine on sideband. Alright, so remember, this right here is your sideband delay. I'll have labels on it though. Alright, so we're at the 1000 watt slug. This is the Superstar 158 EDX, and actually that thing has 2 IRF 520s in the back of it. So you're looking at about 12 bird, which I know is less than he's going to be driving it at, and about 40 to 50 peak. 40 to 50 peak watts. I'm sorry, sometimes this thing has very much trouble. Oh, that's off the scale. It's over 1000 watts. Unless you just hear it talking on sideband. Oh, what's this thing doing? I'm just talking on sideband, just cruise and brake. Now you can tell this thing's being driven a little bit. Hey, what's this thing doing, man? Huh? What is it doing now? Oh, I think this thing's swinging about 28 amps. Put your thing there, getting down, getting down. There you go, it's off the scale. It's doing right at about 1100 or so peak at that moment. So, in RMS wise, you're not going to be getting too much more. I mean, we're only increasing to about 12 bird, but just for the heck of it, let's take a look at the RMS. Ooh, it's only doing about 400 bird RMS. And keep in mind, with the attenuator set up, this attenuator right here, which is actually the 10D. If you look at them, you'd think this right here is the bigger attenuator, but that's just because it's made out of resistors. But this right here is the 10 dB attenuator. This right here is the 16. That 10 dB attenuator is actually set up for about double the amount of power I'm giving it right now. I think we set it up pretty much right there around the mid-range of 20 bird or so. Just going by the numbers that he gave us, 20 bird or so. So if you look at it with them numbers, it's already doing over a kilowatt. And on the RMS scale, see on the RMS scale, by the way, when I first started to even tune this box, on the RMS scale, it was already over 1,000 watts. And that's what kind of startled me at first, because I know usually starting off with these a single LDMOS device, you're going to be around 700 or 800 watts RMS. And I was like, whoo, that's high, you know. So that's when I went ahead and modified the box to accept a amp meter. That's the shunt right there. And just so I could monitor the current, because that's what you want to make sure to do, is to never exceed 30 amps. Never exceed 30 amps. If you can keep it around 25 to 28 amps, somewhere around there, that's great. But 30 is too much. 30 is too much. If you want this thing to truly last and run it, you know, just cruise it, try to stay around 20 amps, 25 amps, somewhere around there. But so now that we've shown the output of this bad boy, I really do wish I had me a radio. And see, I thought about hooking up a small amp to try to emulate a bigger radio, but I'm gonna be honest with you, I would rather be safe than sorry when it comes to this type of technology. It'd be different if this is my 5th, 6th, 7th, 8th, 10th one that I've become acquainted with more, know the limitations of it no more. But that's another thing. I'm not going to sit here and act like this is something that it ain't. This device can handle a full SWR, a full mismatch on the output. Right now, if I wanted to, I could cut my coax, and I'm sure a lot of you saw Mr. BBI's videos. I could cut the coax doing, you know, full output and just start arc welding with that bad boy. And as long as you're within the proper amount of voltage, you're not going to hurt it. I mean, if you was up around 55 volts or something crazy like that, yeah, you could damage the device. But these things can be killed easier than a BJT transistor on the input. On the input, if you overdrive this device, you can fry the snot out of it. So I don't want to, you know, make this thing like it's something that it isn't. You've got major pros, major pluses when it comes to this technology. But if you've ever noticed in anything pretty much that you do, you can't never have it all. You've got to let go of a little to get a little. You see what I'm saying? But the cool thing about it is there's other circuits, protection devices that you can add in. One really cool one that the Genius is working on right now is a input protection overdrive device to where you can actually set yourself. to where you know that you will never overdrive that bad boy. So that right there will up the percentage in being built like a brick. You can do a lot of protection to these things, spend a lot of extra money with protection, and get these things up to pretty much 95% unblowable. You know, you got heat, that's an issue. Well, you can do heat like I've got here. You know, it can get even more sophisticated, of course, than this. As you can see, that's the thermal, well, the second revised thermal setup diagram, because that's something old gatekeepers got to do. I've got to draw things out. Like, for example, there's the attenuator switch. You know, if I don't draw things out like this, I have a very, very bad short-term memory. They tested me when I was young for ADD, and they said I didn't have ADD. Well, right before I was about to confess that I supposedly have a short-term memory disorder, there was a second call. I mean, you'd blow your mind how many people call. I know other builders have to deal with the same thing. How many people called, you know, all through the night, first in the morning. I know it's different time zones, you know, different places. But it's, you know, it's probably at the minimum, what, 1 o'clock in California, I think, or something. But anyway, so next I want to show another cool part, which was also requested by the owner, is the fans. We have full variable control over the fans, which is actually a good thing because these fans are powerful. They are AC fans, and he can sit here and have full control over these things and literally turn them all the way off if he wants, and there will be no extra heat. It's done by a very cool circuit, and when you're dealing with AC, you can do that type of stuff and not have to worry about all the excess heat. So what I'm going to go ahead and do is go ahead and wire up the fans and put the top on and just demonstrate how the fans work, and then get the labels put on here and get this bad boy shipped out to you, bud. Alright, give me 1 second. Let me get the fans wired up. Alrighty, I'm back. I actually decided to wait till the next day to continue the video, get me some rest. It was getting kind of early in the morning. So anyway, we'll go ahead and demonstrate the variable control for the fans, which is really neat, really useful if you want to quiet them down. These are some real good high quality AC fans with aluminum, thick aluminum casing. And it's actually got a fine-tune knob on the actual regulator board that you can adjust if you would like. Like, for example, I'm going to go ahead and go all the way down. And if you see, the fans are still spinning, just super slow. For example, if you wanted to, you could get in there and adjust that multi-turn pot to where when you turn it all the way down, they turn completely off, etc. And basically, I just kind of adjust it to where when you turn it all the way down, they're just barely on, so that when you start to turn them up, it starts spinning faster. You know, a pretty smooth transition. And the cool thing about it, if you want to run them down, you ain't got to worry about any excess heat on the device. The device is good for up to 2,000 watts. AC 220 volts, and we are just pulling a small tiny fraction of that. So there you go, bud. There is your first, I don't know what I'm going to call these. Probably call it GK1000 or something like that. I don't know. But the first gatekeeper built LDMOS with a single device, single BLF188XR. So I'll go ahead and get the top mounted on and get this thing packaged up for you. Looking forward to doing some more units using these devices. Mr. Gatekeeper out here around the northeast end of Georgia. I appreciate everybody's patience as usual. It's been about a 2-year duration of getting completely caught up and out of the old hole I dug myself with all the extra work. But sunlight is blaring down on me now. We'll see you. GK's gone. Bye-bye. 73rds.